Hey everyone, Morgan here. We're going to be doing some math problems today, and there's a chance that you have seen things that look just like this in your pre-calculus class, okay? So don't be afraid to rely upon, those skills. So we're talking about first order reactions only today, and there are two equations that we just really need. That the ln of n naught over n equals kt. Now some people remember that from math classes. A equals a naught e to the minus kt. Either way. And then that the half-life of a first order reaction, T1 half, is 0.693 over k. All right, half-life is for a first order is independent of original concentration. That's not true for second order or zeroth order, but we're going to be talking about first order most of the time. Okay, so we've been told that the half-life of a first order reaction is 50 seconds. What's the rate constant? So since T1 half is equal to 0.693 over k, k must equal 0.693 over T1 half, which equals 0.693 divided by 50 seconds. Let's not turn this into an argument about sig figs. When I run that through my calculator, I get 0.014 seconds to the minus 1, or per second. Now, first order rate constants will always have a unit per time, per second, per minute, etc., etc. Okay? We're going to do this a lot because normally we're going to need the rate constant within a question. So now we're asked how much of a 10-gram sample remain after 24 minutes if it decays by first order kinetics and has a half-life of 10 minutes. Okay, so first off, let's get the K. K equals 0.693 over T1 half, which is 0.693 divided by 10 minutes, which is 0.0693 per minute. Now, since we're looking for how much is left, the most convenient way to solve this is the amount left is the amount we started with times e to the negative kt. Now you could solve it this way also. You'll end up doing the same thing in the long run. So we started with 10.0 grams. That was our sample. Times e to the negative, open up my parentheses, kt. So that is k 0.0693, 1 over minute, times 24 minutes. Now, I have to make sure that these two time units cancel. They must be in the same unit. Minute and minute cancels. Okay? So let me show you a nice convenient way of actually doing this on the graphing calculator. The first thing we're going to do, slide this up so you can see both of them, is we're going to put in the 10.0 grams. Then we're going to multiply that by second e to the x negative 0.0693 times 24, close the parentheses. It equals 1.895, so to 2 sig figs, that's 1.9. And that actually makes sense, because if we think about it, I have a 10-gram sample. Half-life is 10 minutes. So divide by 2, that gives me 5. That's 10 minutes down. Divide by 2, that gives me 2.5. That's a total of 20 minutes down. Now, I can't divide by 2 again. If I did, that would mean 30 minutes. That would take me to 1.25. But I'm only going for 24 minutes. So my answer is between 2.5 and 1.25. About 40% of the way between there. 1.8 to 1.9 makes sense. 1.9 grams. We're good. Okay. Now, for the next one here. Reaction is first order, half-life is 30 minutes. How long will it take for 10% of the sample to remain? So, ln n naught over n equals kt. I'm going to be looking for time. Sorry, the printer's suddenly running over there. I'm going to need my k. So k is 0.693 divided by the half-life, which is 30 minutes. That equals 0.0231 per minute. So here I can say T equals ln of n naught over n divided by k. K is 0.0231, and since this is minute to the minus 1, minute ends up upstairs. Ln of. Now, 10% of a sample to remain. Why don't I just assume we're starting with 100% and 10% of it remains? So that's the natural logarithm of 10. So the natural logarithm of 10, boom, divided by 0.0231, and I'm getting about 99.679 minutes. So looking at call it 4 sig, make it 99.68. That'll make it 99.68 minutes. Okay. Now, for number 4, I've changed the wording. Here's a rate constant. How long will it take for 30% of a sample to be gone? So it's the same basic question. Ln of n naught over n divided by k, 0.500 per minute. Now, starting with 100%, but since it says 30% to be gone, that means my final amount is 70%. Okay? So always make sure you read the question carefully. And this comes out to be about 0.713 minutes. Okay? Which I'd probably convert to seconds, in a real-world situation. Okay. Now, if a reaction is 37% complete in 37 seconds, what is the rate constant and half-life of this reaction? Okay. Ln of n naught over n equals kt. I'll get my rate constant first. K equals ln of 100% to start with, 37% complete means 63 to finish with, in 37 seconds. And on my calculator, that's 0.0125 per second. So then the half-life, T1 half, is 0.693 over 0.0125 per second. Second comes upstairs, and that is 55.5 seconds. All right. So let me re-show the top half of this page for a moment. Pause if necessary. Let me re-show the bottom half of the page. Pause if necessary. Okay, that's Morgan, signing out.